Today we're going to be looking at William Osman's channel, specifically the very heavily requested built my own X-ray after a hospital charged me $69,210.32. Must be American health. It's insane how expensive that is. Those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's check this one out.
I'm William, and I'm $69,210.32 in medical debt.
Well, and your insurance just pays a little over a tenth of that.
I have an engineering degree, electrical and mechanical, and I would love to build my own medical equipment to prove that $69,000 is insane.
Unfortunately, you're not paying 69 grand for an X-ray. It's because the system is broken. But yeah, 69 grand. Forget making one. You could actually buy one for less than that. There's some that are on the order of $40,000. I mean, granted, there are expensive ones that can get into the several $100,000 range, but depends what you're trying to do.
No, we have medical insurance. You don't need a grave. Your responsibility is $2,491.
Wait, so I don't owe $69,000?
No, we have medical insurance.
It was a fake out. That first piece of paper must have been different than what they actually got, because it just said insurance only paid like 8 grand out of the 69.
That means we have plenty of time and budget to make an X-ray machine in the garage. This 60,000 volt power supply I got on eBay for $400. 60,000 volts! Turning it on.
Oh, he's doing the crazy styropyro thing, isn't he?
Oh my god. And for $155, I got this X-ray vacuum tube that I pulled out of an old dental X-ray head bought on eBay.
Again with getting all this crazy stuff on eBay.
I just had to drain a bunch of oil and rip off the broken high voltage circuitry, and bada bing, bada boom. Got yourself a X-ray tube. Now I know some of you are probably thinking, William, you're not nearly responsible or smart enough to be playing with high voltage. Well, I say to you, pound sand. I have health insurance, and my will to do science is significantly stronger than my will to live. No, it's not. No, I'm just trying to say that I would rather do science
He's pretty silly.
and die than not do science. All we have to do is get the high voltage out of the danger box and into the X-ray tube. Should be easy, right?
So let's back up a little bit. So X-rays are a type of electromagnetic radiation. They are ionizing radiation, which means it's strong enough to take electrons off of atoms. So it's just like visible light, but with way higher energy. And they can pass through certain materials, including your body, and can be captured on detectors. The machine consists of a tube that produces X-rays, and there's a filament, a bit like a light bulb, and a metal target. When current is passed through the filament, it heats up, producing electrons, and then they're accelerated towards that metal target by a high voltage. They're going to collide with that metal target and suddenly decelerate, and that rapid deceleration causes X-rays to be produced. Then they're focused into a beam that passes through the body, and it interacts with the body in different ways. Dense structures like bones absorb more X-rays, so they show up white, whereas soft tissues like muscles and organs, more X-rays pass through them, so they're darker. You don't see them as much. And then the image is captured, processed by a computer, and then the technician takes a look at it and can visualize your bones to see if they're broken, also look at your organs and other tissues as well. So that's the goal. Let's see what other homemade products he's going to use to make an inexpensive X-ray machine.
This red wire wired up to positive, and this black wire wired up to ground, and I'll just turn the power supply on and see what happens. Ready? Turning it on.
Of course. More massive arcing. I'm getting some serious electro boom vibes, actually, from watching this.
Turning it off.
Yeah.
Interesting. See, none of our wires are touching,
At least he
so I'm
stood
not really
far
sure
away
why the
from
electricity is not flowing through them. Let's try moving this wire a little bit further away and see what happens. All right, turning it on again. Huh. That's not right either. Welcome to the world of high voltage, where everything's wire and you're probably gonna die. okay, I have an idea. If you look right here, this resistor that was a part of the high voltage supply, and it's kind of leaning a little bit over the tube. So let's move, I hate touching this. Let's just move that this way.
Please tell me you disconnected it first.
Now we're turning it on. Oh yeah.
No arcs.
Oh yeah, you can hear it hissing. I really want to get the microphone
subtle.
over there, but I'm scared of frying it. All right, let's turn the box off. Ow, ow. Why is this shocking me? This is the box. It's not arcing, not big arcs at least, which means we're on the right track.
Arcs.
So now we need to work on the next step, which is turning the tube on. We actually need 2 power supplies because up until this point, we haven't actually been making any X-rays. That's what this power supply is for. This is just a regular power supply. We don't need high voltage here. We need to activate a filament, which is kind of like a little light bulb in the back end of the X-ray tube. The filament boils off electrons, which then get launched to this piece of heavy metal, this copper color thing right in the middle, and then that ejects
Metal's typically tungsten.
X-rays through this aperture at the bottom of the container. Let's go ahead and hook this bad boy up. According to the X-ray tube data sheet, the filament ground should be right here. I guess we'll just plug it in and see what happens. Let's do 3.5 volts. We're gonna turn our current all the way down, so it's current limited. And then as I turn the current,
yeah, that's the one that just makes a little bit of current. You don't need your high voltage for that one. So yeah, the 2 separate power supplies make sense.
We should hopefully see something happen. No? I'm an idiot. I had the probe hooked onto the piece of wire insulation and not the wire itself. Slowly increase the current.
If we did that with high voltage, it might just jump around it anyway, as I've seen in several of Electro Boom's videos.
Oh, you see it glowing? Oh, that's so cool.
There you go.
Okay. Oh, that's awesome. All right, I'm gonna turn it off now. Little Willies, we're about 30 seconds away from making X-rays. All we have to do is turn both plies on at the same time. But before we do that, we need to take some safety precautions.
There you go.
Because here on the William Osman channel, safety is our #1 priority.
Safety is our #1 priority. Well, maybe he's just talking about radiological safety, whereas the electrical stuff, just a couple of ticks below Electro Boom is good.
I bought 2 radiation detectors. I bought a giant roll of lead sheet metal, and I'm gonna repurpose parts from the dental X-ray head to protect some of my most valuable assets. The Geiger counter is directly underneath. Personal Geiger counter is going in my...
Really? I might need a moment. Most valuable assets, indeed. The one little aspect of truth is reproductive cells are more susceptible to harm from radiation compared to other cells because they're fast dividing. And what radiation does is it causes breakages in the DNA strands of cells. And well, fast dividing cells, there's already a lot of DNA manipulation going on already just because they're making more cells. So adding a little bit of a radiation kicker to that, the risk of problem goes up relative to normal cells. You mentioned dental X-ray. The dose you get from that is minuscule. It's about 5 microsieverts, or the same amount of dose you would get from eating 50 bananas. Compare that to the federal dose limit of 1,000 microsieverts. Now I'm talking whole body dose when I say that, not to a targeted body part. Chest X-rays are significantly higher at 100 microsieverts. But hey, a little bit of lead, it will technically do something. It will attenuate some X-rays and preventing them from reaching the target. But is it necessary? Well, no, but I'm curious what he's gonna do with this thing.
Oh, we're gonna turn the small power supply on with the current all the way down, turning the high voltage on, and then we're gonna slowly increase the current.
So it looks like he's at about twice background from this source of X-rays, according to his Geiger-Muller counter. Now you'll notice the unit said CPM is in counts per minute. Now, a Geiger counter can detect them, but what it does is it's detecting a complete ionization of the gas that's inside that thing. Now, a lot of X-rays, compared to other types of ionizing radiation, are pretty weak and pretty short-lived, so it's possible that a lot of them won't be detected. Now, what a Geiger counter is good for is just detecting the presence of radiation or that there may be a contaminated surface or something like that. But the key factor is measure it relative to background. So it's doing its job in saying, hey, here be radiation. Now, the Geiger counter by itself doesn't know that it's an X-ray. It could be anything. But obviously he knows it's an X-ray because he's using his homemade X-ray machine. But as far as measuring the dose rate, for X-rays specifically, it's going to be an underestimate.
The Geiger counter is very angry with us. This is a good thing. It means we made X-rays in the garage. We're generating X-rays, but we still need to capture the image. That's what this intensifying screen is for. Can you guess where I bought it? We can create an image with the phosphor screen. When we run X-rays through it, they turn into visible light in the phosphor, and that visible light can then be measured by us with either a camera or with a piece of film. So if we stick our phosphor...
Now, I've only mainly played with X-ray machines in the context of a lab when I was in college. Yeah, this is pretty old school. Usually you'd use a digital sensor in most cases now, plus you have the added benefit, and the main reason is film just takes a while. I remember when I was a kid going to the dentist, we'd do X-rays first, and then by the end of the appointment, the X-rays might be visible. Now they just show up on your computer. It's just like using any camera now versus cameras in the pre-digital era.
Screen on the ground below the X-ray generator, and we put 4 soda cans on top of it, and then put this piece of acrylic on top of that, and then we put a subject, like maybe real human finger bones cast in ballistics gel.
I know he's going for the cheapest option, but this is funny.
We should see this film glow with the shadow of finger bones cast on it. That's cool. I'm
loving the simplistic
Let's fire off some X-rays right now and see if we can get the sheet to glow at all. It might be too bright in here. I've set the A7S to a 15-second shutter.
I think that's his challenge, is just to try to make an X-ray machine as cheap as he possibly can. It's kind of a way to prove to the hospital that billed him an outrageously high price.
64,000 ISO. All right, high voltage on. All right, I think we got a picture. Oh, look at this. We totally have an image. That is so cool. The contrast is really bad, but I wonder if we can fix that in
Sure,
Photoshop.
that's something.
This is awesome. I think this is really amazing. I mean, this is an actual X-ray of real human bones. This is my magnum opus, the most dangerous contraption I have ever built. It's an actual working X-ray machine made out of garbanzo beans, baked beans.
To be fair, the most dangerous part of that would actually be the high voltage power supply that was causing crazy amounts of arcs. That's going to kill you a lot faster than, and it would take you a while sitting in front of this X-ray machine. But how I mentioned the dose limit was 1,000 microsieverts per year. That's nowhere close to deadly. That was the dose limit for the general public. The dose limit for radiation workers, now he would be a radiation worker in this context, is 50,000 microsieverts per year. The threshold at which the bad stuff starts happening, meaning an increased risk of cancer, is about 100,000 microsieverts per year. Now again, I'm talking whole body doses, not targeted doses in radiation therapy. Those are much higher, but it's supposed to be, because your goal is to kill cells, the bad cells, the cancerous cells. And then into the full sieverts range, or in the millions of microsieverts, 2 million, 4 million, death is highly possible. And when you get towards the end to 10 million, then death is certain. It's more of how long are you gonna last, and it's a horrific way to go with acute radiation poisoning. Now, the radiation dose is not the most dangerous part about this thing right now. It's gonna be the crazy electrical stuff.
Canned tuna, New England clam chowder, a piece of leaded glass, an intensifying screen, a broken dental X-ray head, and a power supply that came out of a college lab and has been beaten to the brink of death. There's something I want to talk to you guys about. Safety. And the relative nature of it. Because I can already feel the safety nerds 2 feet up into my butt.
I'm one of them.
I'm gonna lose it. This is dangerous, but it's not that dangerous. Have you ever been in a car? Have you ever gone to the doctor and gotten an x-ray? Have you gotten a CT scan? Dear God, let's talk about the amount of radiation exposure you get from a CT scan. And what is radiation?
A CT scan is going to be about 10,000 microsieverts, though it's targeted to whatever you're CT scanning.
Rays do statistically increase your odds of getting cancer later in life. Statistically, if you keep your exposure to a minimum, you are perfectly safe. This is why x-rays are allowed for medical purposes. And a small number of stray x-rays that do end up leaving the setup and hitting me or anybody near here are nothing compared to getting on an airplane, getting a CT scan, getting an x-ray, or just living your life and being exposed to background radiation.
Average background radiation per day, now this varies widely, is about 10 microsieverts, though, and keep in mind the 1,000 a year thing excludes background radiation. The big thing is how close you live to a source of radon, which you get from uranium and thorium ore. That's probably the biggest variable.
Being said, I'm still gonna put this iron dome around the whole thing because it's gonna look sick. Yeah. Oh my God, William, is that lead? Lead is really dangerous. Oh my God, is that a safety nerd? Safety nerds are annoying. Think of all the scientists that died over our history of doing science. Those are the only ones you think about.
So the thing about lead is highly, if it's stopping gamma radiation and x-rays, x-rays aren't even going to get very far because they're basically just lower energy gamma radiation. 8 inches of lead will stop almost any gamma source. So yeah, a thin amount of lead's going to stop a lot of x-rays.
The only ones they tell you about in school are the cool scientists who died doing science. No one ever talks about the safety nerds. The iron dome is in place. This means it is time to turn on the x-ray machine. There's no way x-rays are gonna get through these gaps or this giant hole on the side. I caved to the safety nerds.
Hey, again, it's just about minimizing it, and the principle is as low as reasonably achievable. Now, is what he's doing making his own x-ray machine reasonable? Well, I'll let you decide.
Put warnings on it. Let me show you. Hopefully this makes it really clear that it's dangerous and you need to stay away from it. We got real x-ray machine. The radiation warning symbol.
Oh my God. If it's a hissin.
It's a hissin, x-rays, it's a pissin.
I wonder if I could get people at nuclear power plants to make safety signs that look something like this. I guarantee you that'll get someone's attention. The thing is, though, a lot of signs are so saturated that a lot of people who work around hazards, whether it be radiation or electrical or heat, are a lot ingrained. So changing it up with something silly like this, not a bad idea to do this every once in a while.
And finally, a little something for people who have no idea what radiation or x-rays is. Protect my guard dogs. Look how ferocious the dogs are. They'll take one look at those bad puppies. First, let's turn it on to make sure that it actually works.
To be fair, guard dogs would actually be fairly effective at protecting from radiation, mainly because their bodies would get in front of it. So for x-rays, for these relatively low x-rays, they would absorb the radiation and not you. So guard dogs could actually protect you from radiation.
I haven't turned it on since I set all this stuff around it. Got my personal dose meter going. It keeps turning off. I'm not sure if I'm using it wrong or if it's broken. Whatever. Interesting, the x-rays seem to be leaving the shield.
I mean, they go through it, they go around it.
That's a bad sound. It's popping to a can of beans.
There's your dangerous part.
Why are the beans so close?
Forget the radiation.
This is getting ridiculous. Fixed the problem, had to replace the metal bean cans with cardboard boxes. It kept arcing from, I think what was happening, I think that...
High voltage causes things to want to jump. If they have conductors on them.
So the sound you hear is like electrons kind of going into the air and they collect on things, and I think they collect on the bean cans and then they arc from the bean cans to ground. I'm pretty sure that's what was happening. So I tried grounding them, that didn't work. I just replaced it with something that doesn't hold electrons as well as bean cans. What's the first thing we're gonna put inside the x-ray machine? How about my actual cell phone recording a video?
Goodbye.
The camera's set up. I'm gonna turn the lights off now. I'm gonna get my flashlight. That's very... I'm not getting shocked nearly as much. I think that the lead is eating all the electrons. This is good news. Okay, let's see how this
stopping, looks. Attenuating,
oh my God.
Sure.
Oh, that's amazing. Oh, it's so much better. Whoa, that's so good. Holy crap. You can see the battery, you can see the camera. You can see the circuitry that like wraps around the
That's not
battery.
bad.
This is so cool. I wonder what the video on the phone looks like. We made an X-ray machine in the garage that takes pretty good pictures for only a couple $1,000. That includes the camera too that I'm borrowing.
Ooh.
Find something to X-ray.
I don't know if it.
Do you want to X-ray my hand?
Is it safe?
Yeah. All right, so you know what to do?
No.
See the switch right here?
You literally told me nothing.
Look at this, look at the switch. See this? See the switch? When I tell you to, you're gonna flick that switch on.
Okay.
You got it? You're like a...
Again, I wouldn't. The reason why I wouldn't use it would be because of all the crazy arcs and them not being in proper conduits and all that sort of thing. The radiation part I'm not concerned about.
The microphone on the camera died, but we were successful in getting an X-ray of a hand. I cannot believe how good it looks. We
That
did
is
it,
cool.
team. We showed the medical industry who's boss. It's us.
There you go.
Thank you for calling X-Ray Tube. This is how can I help you?
Hi, I have a question. How much does an
Oh, they're
X-ray
gonna-
cost if I don't have any insurance?
So it can go from 170 up. So 170 is just the initial visit with the doctor, and
I love it's always gonna, and a lot of it is because a lot of the people at the offices might not even know.
X-rays are more. It's about $70 each site.
Okay, so if I need to get like my hand X-ray, that would be like $250 maybe, $300.
Maybe, or it could be higher. I just can't really say until you come in.
I actually broke my hand a few years ago. It was just a boxer fracture, and they took a lot more than 2 or 3 X-rays in just various positions just to make sure everything's good. So yeah, I could easily see that if it really is $70 a piece, could easily spending upwards of $1,000 on that, and that's just one visit. You'll come back in a few weeks to see how it's healing, and then you come back again in a few more weeks. There'll be a lot of X-rays associated with that can drive up the cost.
Make it go up.
Just if they're doing other testing.
$300 potentially or more. I bet you you could leave urgent care with a bill about the same price as I built this machine for. I'm not gonna get all political because I think everyone should build their own hospital in their garage. The price is right. I don't see why we can't just build our own equipment. We got the internet. How hard is it to find a broken bone in an X-ray? I bet you it's pretty easy.
If you have the means to do things yourself, why not? Now, the Nuclear Regulatory Commission does not regulate X-ray machines because they don't have radioisotopes that linger, and so it's not really there's not a controlled substance, so to speak, since it has to be turned on. Whereas radioisotopes such as, say, uranium or plutonium, they are continuously radioactive, and they have the potential to be used in nuclear power plants or in nuclear weapons, for that matter. But the big thing is, it's not an active source. All you need to do is turn it off. But you would be required to register it and to get an operating license, but all of that you could conceivably do from home. So, hey, you do you. This was really cool to just watch him. I like how he doesn't take it too seriously, and he's, going through great lengths to prove a point. That was very entertaining to watch, and I really appreciate the recommendation. Thank you very much for watching. I'll see you next time.